Okay, grade 12s, I want you to look at this arithmetic sequence quickly. 2, 5, 8, 11 going on. Okay, they're separated by semicolons, and we up to now can work out the 100th term using Tn as a plus n minus 1d. But what if I do this? If I ask you to add the terms, so I start going like this: 2 plus 5 plus 8 plus 11 plus 14 going on. When we do this, we no longer, this is called a sequence here, that is called an arithmetic sequence, but now we call this an arithmetic series. We're now adding or subtracting the terms. Now, there's a wonderful formula that you can use to help you do this. And what we do is we use a formula Sn, and they give this to you on a formula sheet. It looks like it's n over 2, 2a plus n minus 1d. This is the formula for adding up the terms of an arithmetic series. Okay, and it's very, very cool, this. Okay, and I'm going to show you an example of how we do it and why it works. Let's have a look at this. Okay, I'm going to give you, let's take an example here. I'm going to give you a series, 2 plus 6 plus 10. We're going to add 4, so it's arithmetic and we keep adding. If I said to you, work out the sum of the first 3 terms. The sum of the first 3 terms. Well, you could clearly see that it's 2 plus 6 plus 10 is 18. But now, let me use this little new formula that I'm giving you. They give it to you on a formula sheet in the exams. Okay, this is working with the summing of the terms. Let's sum the first 3 terms. Well, there's 3. The n is 3. What's the a? The a is equal to 2. The constant difference is 4. The number of terms is 3. So that's 2 multiplied by the a plus the n is 3. 3 terms, subtract 1 multiplied by the constant difference. Now have a look at this. That's 3 over 2 into 4 plus. That's 3 minus 1 is 2 times 4 is 8. Which gives me 3 over 2 multiplied by 12. Well, 2 goes into 12, 6 3s are 18. So look at that, it works. 2 plus 6 plus 10 is 18. The sum of the first 3 terms is 18. And if you use that formula, it works as well. So now we're in a position to maybe work out the sum of the first 100 terms. So if we want to go the sum of the first 100 terms, let's have a look at our formula. It would be quite difficult to do this because you have to expand it 100 times. Okay, and that would be tricky. So let's have a look here. It's going to be 100 over 2, n over 2, 2a, which is 2, plus 100 minus 1, which is 99, multiplied by the d. Okay, and if you look at that, that will then give you, if you think about it carefully, if you work that out in a calculator straightforward, it comes to 20,000. Okay, so it helps us, so the formula Sn is n over 2, 2a plus n minus 1d, helps us to determine the sum of the first 100 terms of the arithmetic series. Okay, now let me link up the term formula and the sum formula in this example. If I said to you, determine the sum of the series, and I give it to you 2 plus 6 plus 10 plus 14 all the way up to 598. So that's the last term. Okay, it's in the series there. It's the last term, and we want to add them up. Now the problem is, I don't know about you, I don't know how many terms I must add up. In other words, I don't know what this term's position is. It's a term with an unknown position, 598, I don't know. If I know what its position is, I will know how many terms to add up. I know it's arithmetic, so the first term is 2. The constant difference is, of course, I'm going to give you 4. Okay, and we've got a term with an unknown position, which we want to work out. Okay, and have a look at this. We've got, if you think about it now, to do that, we're going to use the formula for the nth term of an arithmetic. Okay, well, we've got the term with the unknown position is that. The first term is 2. We don't know what n is. That's locating its position. And the constant difference is 4. So let's see what n is. So it's 598 is equal to 2 into 4n minus 4. Okay, so 598 would then be equal to 4n minus 2. 2 minus 4 is negative 2. And bring that across so we get 600 is equal to 4n. And divide both sides by 4, and n is 150. So in fact, this guy becomes the 150th term. So there's 150 terms that we need to add up. Now what you could do is you could say Sn is n over 2, 2a plus n minus 1d. So the sum of the first 150 terms would be 150 over 2 into 2 multiplied by the first term, which is 2, and the constant difference, and then we got 150 minus 1. The constant difference is, of course, 4. Okay, great. If you work that out in a calculator, it's 45,000. By the way, there's another version of a formula. If you've got the last term, you could actually use this formula, a plus L for the last term. That is actually the last term. That's also given on the formula sheet. So you could use this formula for the summing of the first n terms of the arithmetic, or you could use this one as well, which is wonderful if you've got the last term, which in fact we do. The last term, this is the last term, which is 598. So we could go into this formula as well. The sum of the first 150 terms, 150 over 2. The first term is 2, and the last term is 598. There we go, 598. And it will actually work as well. You don't even worry about D here, and you get 45,000. That's if you're given the last term. Okay, which is pretty cool. So you could have used either or of those formulas.